problem, letter A. We have xs is equal to 5 over s cubed minus s squared minus 6s. So to find the inverse Laplace transformation of 5, we will factor this. So we have s plus 2 multiplied by s minus 3. So we will solve this in in partial fraction. So we have inverse Laplace transformation of a over s plus b over s plus 2 plus c over s minus 3. So in solving this, we will gonna use a method, which is 5 over s times s plus 2 multiplied by s minus 3 is equal to a over s plus b over s plus 2 plus c over s minus 3. And to find the value of a, we have a is equal to 5 will cancel s, so our denominator is s plus 2 divided by s minus 3. So the value of our s is equal to 0. So to substitute the value of our s, we have this will gonna be equal to negative 0.83. And to solve the value of b is equal to 5. So s plus 2 will cancel that. And left is s multiplied by s minus 3. So our s is equal to negative 2. And to substitute that, this will be equal to 0.5. And to solve the value of c, we have 5 over s and we'll cancel s minus 3. So left is s multiplied by s plus 2. And the value of rs, since s minus 3, the value is 3. So to substitute the value of s, which is 3, this can be equal to 0.33. So we have inverse Laplace transformation of, we'll substitute the value of a, which is negative 0.83 over s plus value of b is 0.5 over s plus 2 plus 0.33, which is the value of rc, over s minus 3. And this can be equal to negative 0.83 plus 0.5 e raised, which this is positive 2, our e is raised to negative 2t, plus 0.33 e raised to 3t. And this is our final answer. So in letter B, we have x of s is equal to 2s minus 3 over s cubed minus 10s squared plus 25s. So this, to get the inverse Laplace transformation, we have 2s minus 3 over s cubed minus 10s squared plus 25s. And 2s minus 3, we will factor out the denominator. This can be equal to s times s minus 5 squared. And we have inverse Laplace transformation of a over s plus b over s minus 5 plus c over s minus 5 squared. So using the method, we have 2s minus 3 over s times s minus 5 squared is equal to a over s plus b over s minus 5 plus c over s minus 5 squared. And to find the value of a, we have a is equal to 2s minus 3 over s minus 5 squared. And the value of our s is equal to 0. And to substitute that, this can be equal to negative 0.12. And to find the value of our letter C, since it is squared ang denominator, we will use derivative. So we have d over ds of 2s minus 3 over s, and our s is equal to 5 since it is negative 5. So in calculator, this can be equal to 0.12. And to solve the value of our b, we will use coefficient mode, which is our 2s minus 3 over s times s minus 5 squared is equal to a over s plus b over s minus 5 plus c over s minus 5 squared. And we will multiply this in our denominator, which is s times s minus 5 squared. And we have 2s minus 3 is equal to a s minus 5 squared plus b s times s minus 5 plus cs. So the value of our a is negative 0.12 times s minus 5 squared plus b s times s minus 5. The value of our c is 0.12 s. This can be equal to negative 0.12, and to expand this, s minus 5 squared can be equal to s squared minus 10s plus 25 plus b s times s minus 5 plus 0.12 s. And to solve for the coefficient of s squared, this can be equal to 0. 0 is equal to s squared is negative 0.12 plus b. So the value of our b is equal to 0.12. And to find the inverse Laplace transformation, yan, have a is over s plus b over s minus 5 plus c over s minus 5 squared. And we will substitute the value of a is negative 0.12 over s plus 0.12 over s minus 5 plus the value of our c is 0.12 over s minus 5 squared. And this can be equal to negative 0.12 inverse Laplace transformation of 1 over s plus 0.12 inverse Laplace transformation of 1 over s minus 5 plus 0.12 inverse Laplace transformation of 1 over s minus 5 squared. And continue, we have 0.12 inverse Laplace transformation of 1 over s plus 0.12 inverse Laplace transformation of 1 over s minus 5 plus 0.12 e raised to 5t plus inverse Laplace transformation of 1 over s squared. And this can be equal to 0.12 plus 0.12. This is the value of the inverse Laplace transformation. This is e raised to 5t plus 0.12 e raised to 5t, and this is the value of this is equal to t, and this is our final answer. Our C problem, we have xs is equal to s squared minus 1 over s raised to 4 plus 16 s squared. So we will find the inverse Laplace transformation of s squared minus 1 over s4 plus 16 s squared. And we will factor out the denominator, which is equal to s squared over multiplied by s minus 4 plus multiplied by s plus 4. And they will use partial fraction. We have inverse Laplace transformation of a over s squared plus b over s minus 4 plus c over s plus 4. And use CAM method, we'll have our a is equal to s squared minus 1 over s minus 4 times s plus 4. And the value of our s is equal to 0. And to substitute that, our calculator, this can be equal to 1 over 16. And for our b, we have s squared minus 1 all over s squared times s plus 4. And our s is value is equal to 4. So substitute that, this can be equal to 15 over 128. In our letter C, we have s squared minus 1 all over s squared times s minus 4. And the value of our s is s equals to negative 4. This can be equal to negative 15 over 128. And to substitute that, we have inverse Laplace transformation of 1 over 16 over s squared plus the value of our b is 15 over 128 over s minus 4 plus the value of our c is 15 over 128 over s plus 4. And this can be equal to 1 over 16 e raised to t plus 15 over 128 e raised to 40 minus 15 over 128 e raised to negative 40. And this is our final answer. For our letter D problem, we have x of s is equal to 3s minus 5 all over s times s squared minus 2s plus 5. So we have inverse Laplace transformation of 3s minus 5 all over s times s squared minus 2s plus 5. And we will make it into the partial fraction. Inverse Laplace transformation of a over s plus bs plus c all over s squared minus 2s plus 5. And to solve our a, we'll use a method, which is a is equal to 3s minus 5 all over s squared minus 2s plus 5. And the value of our s is equal to 1. To substitute that, value of our s is equal to 0. Sorry. And to substitute that, this can be equal to negative 1. And to solve our b and c, we will use coefficient method. So we have 3s minus 5 all over s times s squared minus 2s plus 5 is equal to a over s plus b s plus c all over s squared minus 2s plus 5. And we will multiply this into our denominator, which is s times s squared minus 2s plus 5. and we have 3s minus 5 is equal to a times s squared minus 2s plus 5 plus bs squared plus cs. So we have 3s minus 5 is equal to, our a is negative 1 times s squared minus 2s plus 5 plus bs squared plus cs. To find the coefficient of s squared, we have 0, this is equal to 0, and our s squared is negative 1 plus b, which is rb is equal to 1. And to find the coefficient of s, this can be equal to, our s is 3, and s is negative 2, s negative 2 times negative 1 is equal to 2 plus c. So our c is equal to 1 because 3 minus 2 is 1. So to substitute that, we have inverse Laplace transformation of negative 1 over s, which our a is negative 1, plus our b is 1 s, and our c is 1 plus 1, all over s squared minus 2s plus 5. Okay, so we have inverse Laplace transformation of, separate this, we have inverse Laplace transformation of 1 over s plus inverse Laplace transformation of 1s plus 1. And to factor this denominator, we have it's going to be equal to s minus minus 1 squared plus 4. So this can be equal to inverse Laplace transformation of 1 over s plus inverse Laplace transformation of s minus 1, because this can be equal to, we can s minus 1 plus 1. So to separate that, we have s minus 1 over s minus 1 squared plus 4 plus 1 over s minus 1 squared plus 4. So we have negative 1 plus e raised to t inverse Laplace transformation of s over s squared plus 4 plus e raised to t inverse Laplace transformation of 1 over s squared plus 4. This can be equal to negative 1 plus e raised to t. And this is equal to cosine 2t plus e raised to t. And we will multiply 1/2 so that this can be equal to inverse Laplace transformation of 2 over s squared plus 4. And for the final answer, we have negative 1 plus e raised to t cosine 2t plus e raised to t times 1/2 sine of 2t. And this is our final answer. In this topic, which is inverse Laplace transformation using partial fractions, it helps me to familiarize the different Laplace transform properties and to solve Laplace transform by according to their forms and properties. And with the help of lecture videos, it teach me how to solve partial fractions easily using CAM method.